Okay, so I will try to do my best to deliver this talk in English. So the topic is that I wanted to try to have LLMs to run locally because of privacy, because of I want to have heat in my home in winter, and all the other aspects of it. I have a question for you. Like, who just randomly puts stuff into your like AI agents and don't care about like what is there, like personal information, just don't care, That's fine. Okay, basically everybody. I expected that because like it's convenient, right? It does the job for you. But actually, it has legal consequences if you do this. You are giving your information to a third party, which may not be the problem. Problem is that it may be used for training the AI, and that is the problem, because then your data are permanently written in some kind of database called LLM, or like in the training data set, which is a problem because these are your private data that are now public, right? That's really bad. So I had few use cases where I really wanted to make sure that my data will stay mine. Do you have any use cases for similar I have? Chemics? So okay. Is this now? Customer data. Okay, customer data. Chemics? The same. Okay.
Manufacturing plan.
Manufacturing plan. Okay. Any other ideas?
Compliance governance.
Compliance. What do you mean by that? Compliance governance.
In a company or audits and the EU.
Like you mean like the documents, and you don't want to put it into AI because they should not be public? Okay.
Well, maybe I was on a project where HIPAA was requirement.
That's great. Yeah. And there are, for example, for the Anthropic, for the cloud LLM, they have HIPAA certified API, but you have to have separate contract for that, and you have to negotiate because it's not there by default. And they have zero retention policy. So it may be legal, but you have to have this contract. Otherwise, it's illegal. Okay, any other ideas what this may be useful for? Okay, I wanted to summarize my private notes. I have like so many private notes with my ideas. I wanted to make to like pick up the main points from it, and I didn't want to put it into the cloud. That's one thing. And second thing that is my company works in assisted reproduction, which is medical. And so we are experimenting with stuff, and I want to have the AI in our product, but I don't want to compromise the user privacy because I really value that privacy. So I wanted to find out some alternative ways to do this. Okay, so let's dive into the first part, what I have for you. Because after the release of the ARM CPU, ARM-based CPU, ARM-based Macs, basically everyone who has this can run LLM on the local machine. It will not be as powerful as ChatGPT or like Claude, but you can do that. And it may be useful for your use case if it's not something super advanced. So how to do that? If you want, now you can go and download this app, or there is LLM Studio, I think, and other apps like this. And this makes it really super simple to run the LLM. It looks like this. And basically, you just download the app. This dialog here pops up, and this is like App Store for LLMs. And you just click here and done. You can use it. Super easy, right? And what is really nice here, they added this indicator here, which says like 55, 59, 41. And this tries to put all the compatibility information from your computer and information from the model. And you can it basically sorts them based on this rank, and you can see how well this model will run on your PC, which is really nice because people not necessarily understands the requirements. Because, for example, here, like you can see, this requires like 4 gigs of memory or 5 gigs of memory. So it computes like how much memory I have. I have just 16 gigs, so basically nothing advanced will run on my computer, but still we can try it out. So basically I just downloaded Gemma 3 and let's ask a question.
So how many, which Gemma 3? There are different ones.
You mean like different quantizations,
Yes.
or?
How many billion parameters does it have?
Well, that's the point. They just choosing something for you, so you don't have to think about it. You know, that's it. Like people who don't know, you know, Gemma 3. Okay, download. That's it. Done. You know, I have it. So okay, and this basically spawns the model on my computer and it tries to answer. And this is running completely locally from this computer on battery. It probably will not be the best answer, but because this is like I'm asking for some concrete information, but that's like not what the LLM is supposed to do, right? It's supposed to work with the text. This is just like I want to show you that it generates some kind of text which seems like English and kind of makes sense. This is good if you have like 64 gig mag or even bigger. Good, you can just download this app and it will work. Nice thing here is that you can also click here and download any model from Hugging Face or Ollama, and there you can choose like the particular type of the model. So this is more like for basic users who want to try it, who have Mac, and basically they will just, like the idea here is probably that you just go through this app store, like LLM store, and you just like download something which has like green circle here and is like matching your use case. That's basically it. So this is like really low barrier for entry. Good thing here is that you can use this also as an interface for API-based models in cloud, or you can also use this for your models that are running on another computer. So you can connect to that. If you have like super like big computer somewhere, you can connect to it and it will work too. Okay. Where is it? Here it is. Okay. So I've seen there is an app store of models, but that one was like child version of app store for models. This is something more like GitHub-ish, where you actually have like really thousands of models, and you can download them, use them, try it out, and you can try it out. You don't have to register there. Just I want you to know that Hugging Face is a repository for models in different kind of formats. Okay, and now, Gemma free on my laptop, that's fine, but I want something more advanced, right? If I want to do like summarization of 50 pages of my notes, it will not work. It will just output something, some random words, because it's just not good enough for my use case. So, what can I do? Like, I can go and buy this card, or 8 of them, even better. Well, and we are done, right? So this is the end of the talk. And now I can summarize my notes. Nice. Or buy flat in Prague. Okay. Instead. Okay, no. Actually, there is a solution. Because something really interesting happened, I think this year, in the field of CPUs. Because AMD released new system on chip from AMD, which is actually really powerful to run AI locally. Because what they did, they added some instructions called AVX 512, right? That can do really fast computation of matrices. And this really, or matrices, and this really sped up the computation so much that it's actually affordable to run it locally. So, okay, you have it, this system on chip, or? Okay.
The AVX is just vectorized computations. That's not actually the GPU. Well,
No, it's not GPU, yeah.
what Peter is talking about is Strix hello, whatever, which is actually a GPU, integrated GPU.
Okay, so there is another system on chip which has integrated GPU called Strix Hello. And okay, yeah, that's right. But I can. That's what you have. No.
No idea, it's a small box and it works.
That's the spirit. Okay, it's a small box and it works. Okay.
He does.
I want that's one way. You can buy this small box. It has the system on chip, and cool thing about that is that it has integrated GPU on the chip, which has access to all the system RAM, which is, I think, 128 gigs of RAM, which is cool because on classic GPUs you just can't buy consumer-grade card with this amount of VRAM, right? And now you can. It's like in order of magnitude slower than the VRAM on the proper GPU, but it's still fast enough for you to run the LLM workload. That's cool. Or there is another thing, which is what I'm going to show you, is that if you can buy the AMD EPYC processor, EPYC CPU, which has this AVX 512 instruction set, and it has even extensions with BF, which means brain float, which is basically this. For engineers, this is like half precision integer, and this is brain float. So it shifts the exponent and the mantissa. So basically, this is more useful for the workloads on the LLMs, but it uses just like half of the memory as the full float 32, which is nice because you can have like half of the RAM and it still works like almost identical like if you have float 32, which is like the original model or original side of the model. So you can buy just normal server grade AMD Ryzen CPU, And thanks to these instructions, you can run the LLM and it will work reasonably fast. I have one server running exactly this configuration, so we can try it out. Do you have any question? We can ask the AI.
I have one.
Okay.
Is the home server that you are hosting in your house?
Exactly. Yeah.
That's a good question. All right. Where are you?
Are you? No.
Also autocomplete. What? What?
No, it must be some browser.
What do you think of having?
What I want to show you here that even it's running on the CPU without the GPU, even like the virtual, it still generates 21 tokens per second, and this is 120 billion parameter OpenAI model. Possible meaning of chemics. Interesting. You're a web-based. Okay.
How did you get it?
Chemics, do you have any more questions?
Soft library on my package.
Well, I learned something new. Cool. So this has been running, or this is running on server-grade CPU without any GPU. There is no GPU on this server. So, it has like 128 gigs of RAM.
Billion parameters.
Yeah,
It's large.
that's a large model. That's a large model, and it can do the full 128,000 tokens of context. And I'm even able to run 2 questions in parallel on this. So it works basically the same speed. So
It doesn't halve the token.
yeah, it will. But then it's still 60,000 tokens for context, so that's still good enough.
Ask it to write some code.
Python.
This is still running on the one CPU.
With many cores.
With many cores, yeah. There are, I think, 16 of them. I'm not sure. We can check it out. Here is, and the fun thing is that it's even running in the hypervisor. It's actually not on the bare metal. It's running on the LXC in Linux. So we can see here that it's actually using some CPU. It should. Yeah, there is some memory usage here. Yeah, we can see the usage here.
28 CPUs.
Yeah, but it's a virtual course, so it's half of them. It's 16 physical cores, and it still runs like pretty decent speed, right? And this is still like the 120 billion parameters model. So this is like the big model that OpenAI open sourced. And it's an interesting thing is that it's not running quantized version, it's running the brain float 16. So this is like the basically the full version of the model. It's still... I've been trying like how does it work with the context, because there should be like significant decrease of the speed when you have more context, and there is. When I just like throw like approximately like 50 pages of text to it, well, it's slow, right? But still, when you have like system prompt, which is like, I don't know, 2 pages, like, I don't know, 1,000 tokens, and then you have your like user prompt, it's still fast enough. Interesting is that the server has the KV cache, which means that it caches like your conversation, and when there is another conversation which starts with the same with same sentences, let's say, it will just it will not recompute the whole thing. It will just continue the conversation, which is nice. So it's actually quite usable out of the box. Okay, so how I did it, how you can do it too. It's actually not that complicated. I'm running Llama CPP server. They are releasing like 5 times a day, so just like git, just use get master compile, and that's it. And write bash script for that, because you will be doing this every day if you want to have the latest version. And
This is like the most agile project.
they just don't have fear of releasing things. They are just releasing constantly, which I really like.
It's nice.
And the good thing is that it's really standalone thing. You can just go and run this this Llama CPP server, which is like binary, which after you compile it, and it even contains the user interface, which is this, what I've shown you here. So out of the box, you have something which you can use, which is really nice. So you can just play around with that, and it's fine. If you want to make the configuration, because there is like a million parameters here. If you want to make the configuration even simpler, there is a really nice tool from Srigi, which, yeah, he made a wrapper. What it does, it's basically helps you to start the Llama CPP server with all the parameters based on your configuration and based on the configurations you create on the disk for your models. So it just simplifies how you start it, how you start the model. You can use it. It's pretty nice. I use it. I can show you. Here is what we've been doing here. This is the server. You can see the statistics of what we've been generating here, and this is the LLMs repo, where it has configuration LLMs ini with, you can see the secret here, which is secret, and another folder where I just downloaded models from the Hugging Face. Can you see it, or should I make it bigger? I should make it bigger, right?
I have a question. Does anybody else have this collection of models in computer? No. I have like 300 gigabytes of it. I am constantly gardening this collection. Which one is the best? Yeah, we can discuss later. I'm looking forward.
Well, 469 gigs. Well, That was unexpected. Okay, and this the script I've been mentioning here, it works the way that you have like a system configuration where you configure like your preferred way of starting the model. Like if you have the brain float extension, you want to use brain floats there, so we just like put it there, and then you have any file which is just near the model you want to start, and you can just override any parameter here. It's pretty simple wrapper. It just helps you to start a model, so you don't have to write the bash script for each model you want to start. But you can do that too, but this is a bit more simple. And that's basically it, I think. Maybe there is one more thing, one more last thing I want to show you, and that is if you want to share the model with more people, like you have this computer running somewhere and you want to share it with more people, it's not really practical to just directly point them to your API or to this like nice UI, but it's still really like a minimal UI. If you want something more robust, you can use this app called LibraChat, which is also open source. You can just spin it up in Docker, and you just put there a simple configuration file which connects to your Llama CPP server where you are running the model, and then you can just share access to this UI where nobody has to configure anything. It just works. You can just create an account there, and that's it. So we can try to ask something here, something crazy.
Who is coming?
Can you talk to it also? Because I see there the microphone button.
It would be probably only macOS dictation.
Yeah.
I might be.
Yes, I think I can talk to it. But this is like the Mac OS dictation tool.
Ah, okay, I see.
But it works pretty well, right? I'm not sure if I actually spin it up back. Probably not.
Yeah.
Yeah, I haven't launched the model. Yeah, it works. Okay, so let's go for questions.
How did it like cached the question, and once it picked up the connection, it started streaming?
No, I just canceled it and send it again.
Again.
Yeah,
Ah, okay.
I think I will send it again. It's kind of stopped. I don't. Maybe it was still in the warming up process. Yeah, now it works. Okay. Okay, who would like to try to run LLMs locally in your infrastructure? Hands up, please. Okay, that sounds nice.
I don't have the hardware.
You can buy it.
For a few $1,000.
Like
I could.
like I've shown you, right? That's no problem.
I want to see if I can run like the 4 Cloud Sonnet 4.5 on my then I will buy.
I'm sorry. What?
If I am able to run something like Cloud Sonnet 4.5 on my computer easily, then I will buy the hardware.
Something like Claude Code?
Yeah, something like that.
You can actually do that. Do you remember the name? What is that?
The name of the model that is already
Ah.
on bar with so many.
I mean there is, I think it's called SPA, something SWA, something like that, which is basically clone of the cloud code, and you can pair it with local models. So yeah, it's possible. It's possible to do that.
But he was maybe referring to the capability of the model to be able to run many billions that are so clever as Sonic Board.
Hmm?
Yeah.
Because we have this open code, which is like open source cloud code, where you can plug any model, but that's not the problem. The problem is that you need capability to run the model.
Aha, okay. Yeah, so basically we have open source tooling for that, but we need more powerful models for actually running the workload.
But,
Okay.
today there was some really nice announcement. Maybe you can open techpowerup.com.
Like this?
Up, not application, but going up, TechPower Up. Let me try. Okay, it's coming. And there is a new, if you scroll down, maybe try looking for NVIDIA.
Now I feel like MCP server.
Another article. Yeah, this one. Today this was announced. 70 gigabytes. But we don't know the price. But probably it will be 10,000 euros. Should be more affordable.
The RTX 6000 was cheaper, right? Or wasn't? Yeah, I think so, yeah.
Well, that was 96. Today they announced 72 gigabytes.
But this is good anyway because if you start buying these, there's going to be like push down for the aftermarket prices for all those 4090s or whatever was there, which is currently like getting super prices, right? It's like twice
Hmm.
what it should be.
Yeah, maybe, yeah. Or there will be like clones. They will just using chips and doing different cards. That's also possible.
NVIDIA GPUs were selling for the recommended prices.
Hmm.
It would be still okay to build your own home cluster of 4 to 6 of those, and it would be still okay-ish, right? But at this point, the only thing which you can buy yourself at home is the Mac Mini or or the Strix Hub. In my opinion.
Or the AMD Epic. I think because like the different like the difference there is that the Halo has I think just 2 memory channels and the Epic has like 12 of them. So it's really faster.
Like that. Okay, so the problem, if you do the CPU online, the problem is that the prefill is really, really slow. It's like unusable at all. If you ever wanted to,
no.
like, for example, if you ever want to do like the image generation,
Well, yeah.
that's really going
That-
to show
Yeah,
how
yeah.
slow it is. Right?
Yeah. Like, yeah, you're right. The prefill on CPU, like just to compare the numbers on the proper GPU, you can have like prefill, which will be like 8,000 to 16,000 tokens per second.
Yes, yes.
But on the CPU, you get like 60,
That's what
right?
I'm trying to say, because if you want to use it for the code editing or whatever, it just like agent tooling, you're going to have like agent tools like read the file and there's like boom, like 100 lines, right?
Yeah.
And like another 100 lines, another 100 lines, and suddenly you're like waiting for everything and
Yeah, that's right.
it's not really usable, right?
Yeah, that's right. Like the prefill is.
The only model which is like quite usable is the Quad 3 33 slash 3 billion active parameters. That's like that one is like fast enough on the on the like Apple hardware, right? Which you can buy yourself for a reasonable price,
Mhm.
and have it at home and have all the benefits of privacy and security.
Yeah, you're right.
Unfortunately, but by the way, it's like a really good model. I recommend.
Hmm?
I can recommend that model.
Mhm.
When three older, three, three active, whatever. I can send you link.
Okay, cool. Okay, any more questions on this?
Speaking about context management, in the on-prem deployment, who owns the context management? Like the tool, the UI, it is part of the image that runs the LLM model. Where the context is stored, which format is it stored?
Like the limits are from the model itself,
No,
and like where is it stored?
the context is.
Well, in RAM, right? In memory.
So if I restart my machine,
Yeah, it's gone. It's gone. But in with Llama CPP, you can actually they have feature called slots, and you can actually save the KV cache to the disk, and then you can restore it. But there is some management that you have to do about it. This does not happen automatically, but this is the way I think how you can even the CPU make usable for things like coding and this kind of stuff, because then you don't have to reprocess the like at least the system prompt and this kind of stuff. So when you can just like go system prompt and then your task, and there will be no more context, that's fine. You can use this. You can run this on the CPU. It will work well because you can basically cache the whole thing, and then you just like throw the data that you want to work with.
Another question: if you ever tried the hybrid deployment, or if you have, for example,
Can you speak up?
hybrid deployment? If you have
Hybrid.
tried hybrid deployment, like some agents in cloud, some agents on-prem, and they speak with each other.
Well, I think there is nothing which will stop you. Like there are just two APIs. You can connect whatever you want. And I thought that you meant like hybrid deployment, that you have like part of the model on the GPU and part of it on the CPU. That's also possible, and that actually is the way how to run really big models on the GPUs that does not have enough VRAM. So if you combine something like I have, the AMD EPYC, which is actually pretty fast, it has like 500 gigs per second access to the memory, which is pretty decent. You can combine it with some kind of GPU which does not have enough VRAM, but the big part of computation still happens on the GPU, but there will be really a lot of talk on the PCI Express bus.
How often are you updating Llama CPP?
It happens automatically. I made a cron for that because I don't want to think about that. Life is too short to.
Can you share the cron?
Huh?
Can you share the cron?
Just like one line.
No, I mean, but
Like bash update llama cpp.sh.
well,
That's script. That's pretty simple.
You are asking wrong thing. You should ask not for the source file, but the prompt that generates.
Actually, I've written it manually. Well, it's not complicated.
and should it restart as well?
Well, it should.
But it doesn't.
It doesn't.
Yeah.
Next version.
So, are you thinking any time soon going with GPU?
Well, it depends on the prices. So I should put some kind of limit order when the prices drops down, so they will hit my order with the cards. Yes, Chemix?
What was the biggest challenge to success with this installation?
Okay, so what was the biggest challenge to do this installation? That was, well, it was pretty easy because I know Srigi, right? So he just told me like, hey, just we have to try it out. You have this pretty cool CPU. Just let's try it out. So thanks, Srigi. I would probably not try it out without you. And after that, it's like the first experiment. It was pretty fast. We actually done it in pub somewhere. It worked. To make it faster, actually to run at this speed and to have the prefill, which works pretty decently even on the CPU, which is like, I don't know, 50 tokens per second or 60 tokens per second for the prefill. It took me like another 2 hours to finding the right parameters for the CPU, because it really depends on the number of cores, on how big the L2 and L3 cache is on the CPU, like there is hyper-threading, so like I've been experimenting with the allocating the cores and the virtual cores, and because it's running on the hypervisor, there are another VMs running on this stack, so like fiddling with the parameters, that was like the most that took me the most time.
Your time or cloud computing?
Mine time.
And the last question is, what is your next step? How to improve this setup?
Well, my idea is that I would like to find some kind of business case for this in the project we have, and that way it will allow me to buy actually proper GPUs and proper hardware. So then we can even improve the prefill time, and that way it will make even more sense.
Ready now, it's time to ideas and make it real and sales.
Well, now it's time to throw more money at it, and it will work just better. That's it.
Have you ever considered there's like a project that someone's doing where they hook up multiple Mac Minis? Would you consider trying that?
Well, that's absolutely perfect use case for when you want to have a lot of views on YouTube. But besides of that, I would not recommend it, because there is really a huge amount of coordination work between those nodes. And so basically, or there is one, okay, so in the end, you will be probably slower than when you run on the one. That's what usually happens from what I've seen, what people tried. But there is one advantage. If you really need this one advantage, you should use this. And that's it. When you want to run model like DeepSeek R1, which has, I don't know, 500 gigs or something like that, then you need to like make a cluster of computers you have available. It will still be slow, but it will run, because there will be enough RAM, right?
Care about speed.
Yeah.
Is this CPU with Zen 5 architecture?
Yes. Yeah.
And did it use NVIDIA and no accelerator? Yeah, there is no accelerator in this board.
Well, I'm just not sure that there is a whatever. It probably stopped the screen. Just continue. I'm sorry. Please, can you repeat the question?
Models or Lama, if it use NVIDIA accelerator.
Like the neuron accelerator? Well, I don't know. Like on my hardware, probably not. Well,
Is on Z5, there should be fast accelerator.
maybe. I'm not sure. we can try to Google that, but I'm not sure. Yeah, it's okay.
Just want to double check the speeds you were mentioning because I am looking at the mini PC with Kuchař and the same model. It has 250 coins per second for graphical and 50 for generic. But you were mentioning lower numbers with your giant server, so it can't be that right.
I think it can be right because my server CPU does not have any GPU. That means that it's running strictly on the AVX 512 instructions. And what people usually do with these Halo PCs, they use Vulkan driver to use the kind of GPU which is in the CPU, which allows them to access like more parallelization in the processing, which affects the prefill speed mostly.
Well, that means that your giant server is probably slower, but it can handle parallel requests. Where the mini PC is faster, but can only do one at a time.
No, I don't think so. I think it will work the same. I think it will work the same. I think you can have parallel requests even on the small PC. Just I think the difference is that with the server, I can have much more memory there because I can just put more sticks of memory there and it will work. But with the Halo, there is fixed 128 gigs and that's it.
Yeah, can I have one question regarding the data type? Is the BF16 like in which way it is more friendly for the CPU? Why is it? Because usually when I'm downloading any models for the Apple, I'm downloading Q8, not to BF or F.
Yeah, you're doing it right. Yeah.
That one is fast, the fastest. But you mentioned BF16. Is the BF16 better for CPU or is it?
No. Like for most CPUs, it's worse. It will be slower, and only reason why I use it is that because I know that my CPU has hardware acceleration for BF16. So this Ryzen 5, the server grade CPU has this like on the chip. So no, it's approximately the same. It's approximately the same, but you basically get like on practical level precision of float 32, which is pretty cool, right? It's not technically the same, but because of there is there is like pretty good precision, and even though it's just 16 bits, it's basically similar to for inference. It's very similar results like the F32. Yeah, but on the classic CPU, definitely go for Q8 because with integers it will be faster, or go for F16.
It's also like that for the GPU on Apple because
Yeah, that's the same. Yeah, on most GPUs, just don't use brain floats. It will just not work because they don't support it. Okay, any more questions?
Question about training. Is the CPU has power for training some corpus or something like this? Maybe to do some better model specific for your use case?
Well, it's powerful enough if you have enough centuries. Like you, you will probably need few hundred years to do that on the CPU or single CPU. But yeah, you can do it. And you will need really a lot of RAM because you will need F32 version of the model, like the full size version. And I don't know, like I'm not expert on this, but it's probably not feasible practically. And like, why do you want to do this?
I have idea that I want to per week train some corpus, new emails, and integrate it to the corpus layer to the model.
Well, we can have beer after that, but I'm quite convinced that you don't need it. That you don't need to train the model for achieving this kind of thing.
Because rack.
Hmm?
Because rack.
I think there are other ways you can approach it.
So if it was the last question, so thank you. Honza.